Good afternoon and welcome to Chef Vault, a deep dive. Now, all of us who practice configuration management, particularly when we're first learning it, have probably found ourselves asking this question. What do I do when I need to share static data among my nodes? Let's take a look at an example infrastructure. Let's say we have two application nodes and there's a separate database that they talk to. And then there's a load balancer in front of those application nodes that takes in that traffic from the web and distributes it among the application nodes. Now, both of these app nodes are going to need the credentials to access that database. Now, we could manually SSH into each node and add it, but that feels like it defeats the purpose of automated configuration management. And it becomes even more complicated when I want to add a third node, or a fourth one, or a fifth one, or one of them dies and I have to replace it. In order to keep things sustainable, I need some way to share those credentials among my nodes. Now, a lot of us are probably familiar with the classic chef approach, use a data bag. But what if that information is sensitive? Database credentials are usually pretty sensitive. What if we need to protect that data from unauthorized access by encrypting it? Well, then it gets a little bit more complicated. This is because any tool which manages secrets must not only keep the data safe, it needs to find a balance between security and usability. Now, occasionally when I mention things about securing secrets in the cloud, a response I get is, well, if you really want it to be secure, just put it in a room without internet access, shut the door, don't let anyone in, and then you're fine. Well, that technically might be secure, but it's definitely not usable. Has anyone else heard things like that? Yep, we've got a few hands up. So this is because preventing unauthorized access is only half of any kind of security management. The other half is enabling authorized entities to access what they need when they need it. A way I like to put it is a system that is secure but unusable is inherently insecure. This is because people still need to get work done. People will go around it if it's not usable for them. And often, the more secure something needs to be, the more critical it is to people completing a mission, whether that's a new feature in a corporate environment, or enabling a university to protect a student's information, but be able to access it when someone who's authorized needs it, or even a national security agency that needs to keep its data safe, but also needs to give the people on the ground or in the data centers or wherever access to the information when they need it. So when there are a few, actually more than a few, secrets management tools out there. In order to know which one is best for you, you need to understand, one, your own environment. What mission is your organization attempting to fulfill? What are the risks associated with your type of work? This is critical for picking the best tool for your particular needs. And the second thing you need to know is, once you know your environment, when you're looking at a tool, you need to be able to evaluate the capabilities and limits of that tool in order to assess whether it is the best one for you. This is because no tool is one size fits all. The reason we have a variety of secret management tools is not because everyone just keeps trying to reinvent the wheel, but because different tools meet different needs in different environments. So in this talk, we're going to focus mainly on Chef Vault, but how it works, what environments it works well in, and what limitations it has. But we will also briefly explore alternatives. This is because even if Chef Vault is not the right tool for you, there are others that might fit your needs better, and we'll discuss common questions any organization can ask themselves to figure out which tool is best for their needs. Before we dive in, though, let's cover who I am. I'm Nell Shamrell-Harrington. I'm a core maintainer on both Habitat and Supermarket. I'm also the co-host of the Food Fight podcast, if anyone listens to that. That's a chef-related podcast. You can find me on Twitter at @NellShamrell, or if you have questions or such after this, feel free to email me at nshamrell@chef.io. And looks like some people are taking pictures of it. I'll pause for a moment, but I will be putting this back up at the end of this talk. So before Chef Vault, there were encrypted data bags. Let's use this example of an infrastructure again. We have our application nodes, we have a load balancer in front of them, and we have that common database that all of them need to be able to access. Now, to create an encrypted data bag, let's say I've created a JSON file on my workstation that includes the database password. In order to encrypt this, I first need to create a key. In this case, I'm creating an open SSL key called my key on my workstation. And once that's on my workstation, I can go ahead and create that data bag from the JSON file using the knife data bag from file command. But I'm going to pass one more argument to that command. I need to pass it the path to that key on my workstation that I want to encrypt that data bag with. And once I do that, I will have a data bag with my item inside it, and it's encrypted with my key. If I want to look at what's in this data bag, I would use the knife data bag show command, and again, I would pass it that same key. I need to pass it that particular key anytime I want to decrypt that data bag. And then the info within that item will be passed back and rendered on my workstation. So this looks fairly simple if I'm only trying to access that data bag from my own workstation. But what if multiple people need to access or edit that information? Let's say we have 3 people's workstations that all need to access it. I would need to distribute that exact same key to all of those workstations. And it's not just workstations that will need that key. Every node that needs to be able to access information in that data bag will also need that identical key to decrypt it. So we have one key that we need to distribute to all workstations and all nodes. And that is the main limitation of encrypted data bags. You have to control the sharing and distributing of that key manually. And this introduces security risks. What if someone suddenly leaves your org, particularly involuntarily? We will then need to generate a new key, re-encrypt that data bag with the new key, and then redistribute that new key to every workstation and every node that needs access to that information. So this is a highly manual and very error-prone process. Additionally, if that key is compromised somehow just on one person's workstation or on one node, everything that accesses that data will potentially be compromised. So what I think this highlights is that key rotation is hard. There's no way around that. Managing access to data, making sure the correct people and nodes can access it and the unauthorized ones cannot, is very hard, but it's not impossible. Someone's dragging tables upstairs, I think. But it's not impossible. There are tools out there that help with this problem. Now, I'm not going to tell you they make the problem easy, but they do make it easier. So Chef Vault is one approach to solving this problem. And Chef Vault is a tool that was originally developed by Nordstrom. They saw a need with their use of Chef, created a tool to meet that need, and then open sourced it. It's kind of the open source dream right there. So ownership and maintenance of Vault was transferred to Chef in 2015. And it is completely open source still. If you want to check out the code of it, maybe check out some of the new things that Tom mentioned in the keynote today, head on over to github.com/chef/chefvault. Now, how Chef Vault works on a high level is, let's say we have a Chef server. Now, Chef Vault does work with Chef Solo, but for this example, we're going to focus on using a Chef server. We have 2 nodes that are managed by that Chef server. And when a node is managed by a Chef server, that Chef server has an associated client object on it for each node. That's how Chef server is aware of and how it manages each node. Now, additionally, when a node is managed through Chef server, it uses an RSA key pair to authenticate it. The node itself will retain the private half of that RSA key pair, and the client object on the Chef server will maintain the public half of that pair. That's how the node knows it's talking to the correct Chef server, and how the Chef server knows it's talking to the correct node. Now, like nodes, when we have user accounts on a Chef server, each user is also going to have a client object on that Chef server, and each user is also going to have an RSA key pair. The user will keep the private half of that key pair on their workstation. Usually when we're doing Chef on our workstation, we'll have a .chef directory, and you have to keep a key in it. This is the key that you're putting in it. And likewise, each client object for that user on the Chef server will maintain the public half of that key pair. So what Chef Vault does is it takes advantage of this existing key setup and uses it to encrypt data. So let's say we have a vault. A vault is very similar to a data bag. It also contains items in it. So in this example, I have a vault called my vault and an item in it called my item. Now when I generate this vault, we'll go over how you do that exactly in a moment, but when I generate it, Chef Vault generates a shared key and encrypts the vault with it. So far that probably sounds pretty similar to encrypted data bags, but we're about to see the difference. So let's say that vault is on a Chef server and we have a user account and a node that need to be able to access that vault. Well, remember, each user account and each node has their own RSA key pair associated with them. So what Chef Vault will do is it'll make a copy of that shared key for each user and each node that is authorized to access it. Then what it does is it encrypts that shared key with the key that is particular to the user and the key that is particular to the node. So if we have one user and one node, we're going to have two copies of that shared key, and each one is going to be encrypted by that entity's specific key pair. So that means if user one needs to access to that vault from their workstation, they're first going to use their own key to decrypt that copy of the shared key, and then they will be able to decrypt the vault itself and access the information inside of it. And it's the same thing with the node. When that node needs to access information inside the vault, it's going to use its key pair to decrypt the copy of that shared key, and then use that shared key to decrypt the vault itself. Now, what this highlights is that the approach of Chef Vault is to use layers of encryption to balance that need for security and usability and help make key distribution, again, if not easy, at least easier. So now that we know how Chef Vault works, let's take a look at an example of creating a vault. So let's say we have a Chef server, and I have two nodes registered with it and two user accounts on it. Now, in order to use Chef Vault, I need it installed on my workstation. Now, if you use the Chef DK, I have good news for you. You already have Chef Vault on your workstation, and you are good to go. If you develop Chef without the Chef DK, however, you will need to install it as a gem on your workstation. So once I have that installed, creating a vault is very similar to creating a data bag. I first call the command knife vault create, then I pass it the name of that vault and the name of the item within that vault. And the next thing I pass is I specify which user accounts I want to be able to access that vault using their key pair associated with their Chef server account. And along with that, I also pass in the specific nodes that I want to be able to decrypt that vault. In this case, it's node 1 and node 2. Next, I need to specify which mode I am running Chef Vault in. Again, Chef Vault works with both Chef server setups and Chef solo setups. If I'm using it with Chef server, I'm going to pass client as the mode. If I'm using it with Chef solo, I would pass solo as the mode. And finally, I will pass it in the file with that data, that JSON file I have on my workstation that has those database credentials in it. So once I run this, I'm going to create a vault with my item inside it, but Chef Vault itself is going to generate one more thing. It's going to generate an item called my item keys. And what this includes is all the public keys for all nodes and all users who are authorized to access that vault. Now, if I want to look at what's inside the vault, and I'm using a workstation that has an authorized key on it, I would use the command knife vault show. And again, if I'm authorized to view it, I would get back the decrypted information that is within that item in the vault. Now, if I were running this from a workstation that did not have an authorized key, I would just get back this noise. I would get back the encrypted data, but it would not decrypt it for me, and it doesn't tell me that much about what's in that item itself. So we've covered how Chef Vault works, we've covered how you create a vault. Let's talk about how you would actually use the vault within your own chef cookbooks. And the first thing you need to do to use a vault in a cookbook is you will call the gem chef vault from your metadata.rb file. Then when you get into your recipe, you first need to specify that the gem needs to be installed at compile time. This is because we are going to require Chef Vault in the recipe itself, and that will only work if we install the gem at compile time. Now, if I were doing this require statement in a supporting library or somewhere outside the recipe, then the gem would install at converge time as I expect. But for the sake of keeping this example simple, let's say we're going to call it from the recipe itself. I can then load that vault to my recipe using the chef vault item call, passing in the name of the vault and the item within it that I want to use. And finally, I can use it to set node attributes. Remember, example contains a database password, so I can set that attribute by pulling that information from the vault. Now, I do want to mention, if any of you are wondering if I realized that setting a node attribute to my secret means the secret will be stored unencrypted on my Chef server, yes, that is correct. You can get around this by using certain resources, but again, for the sake of keeping the code on my slides simple, I'm going to use this as an ongoing example. So now we know how to create the vault, we know how to use it in our Chef cookbook. Now let's cover how you maintain a vault, because it's not done when you create it. If I find I need to edit a vault item, say the credentials for that database change, all I need to do is call the knife vault edit command. Again, if I have an authorized workstation, it will open the item in a text editor and I can edit it however I please. Now, if I need to add a user or node to the vault to authorize them to access that vault, I can do that using the knife vault update command and pass either the chef username of the user I want to add or the name of the node that I want to be able to access that item within the vault. Now, if someone leaves our organization or we need to take a node out of it, all I need to run is knife vault remove and again pass in either the username or the node name associated on the Chef server. Now, occasionally, when we use a Chef server, we need to regenerate our keys. In my case, this was right before ChefConf 2 years ago when I was not in the directory that I thought I was, and I accidentally blew away the private half of my RSA key pair. So, if you have to change your key on your Chef server for some reason, you're going to need to refresh it in Vault to let Vault know that that key is now one that's authorized to decrypt it. So you do that running the knife vault refresh command, and that will go through and pull all the keys that are new. Now, destroying a vault requires a few more steps. I first need to delete the items within that vault before I can delete the vault itself. So if I run knife vault delete my vault my item, it's going to delete both those items within the vault, but it's going to leave that empty vault out there. So to get rid of that now empty vault, I need to run the knife databag delete command. I do need to use a databag command to delete the outer vault itself. And once I run this command, then my vault is now gone. So we've seen examples, we've seen theory. Let's look at a real-life example, however, with public supermarket. As I mentioned, I'm a core maintainer on supermarket in general, but for public supermarket, we use Chef Vault to manage our secrets. So this is loosely what the infrastructure of production public supermarket looks like. We have a load balancer, we have a few application nodes, and then we have a separate Postgres database and a separate Redis cache. Now, along with this production environment, in a separate AWS account, we also have a full staging infrastructure. The staging infrastructure uses its own load balancer, its own application nodes, its own Postgres database, and Redis cache. So this means we need to be able to manage different secrets for different environments. So how we do this is we use a vault that we call apps. Then within that vault, we have two items, one for supermarket staging and one for supermarket prod. Now, along with these items, when we created them, Chef Vault created supermarket staging keys and supermarket prod keys for us. So this means that staging nodes will not be able to access the supermarket prod secrets, and prod nodes will not be able to access the staging secrets. That's one way we can keep them as separate as possible. So Chef Vault does work very well for our needs with the public supermarket, but it does limit us in certain ways. And I think it's important to not only understand how Chef Vault works and how to use it, but you also need to understand its limits in order to know if it is the right tool for you. And the biggest limit is with auto-scaling groups. Whenever you add a new node to Chef Vault, you currently need to add that node manually. You need to authorize that node name manually. So this means Chef Vault is not compatible with auto-scaling groups or other self-healing mechanisms. Now, you could theoretically have one node generate all the keys and distribute those as you add new nodes, but that is a major security risk. If that node is compromised, your entire system will be compromised. I see some pictures, so I'm just going to pause for a moment. And lastly, Chef Vault does not keep audit logs of who accesses the vaults. This is a significant limitation when your compliance mandate requires logs of who or what access certain secrets. So now that we know the limits of Chef Vault, let's talk about a few alternatives. And the first I want to highlight is HashiCorp Vault. Yes, it is also called Vault. Yes, it is very confusing. I had to practice this talk a number of times just to not say the wrong one when I met the other one. So the cool thing about HashiCorp Vault is it allows you to create dynamic secrets, secrets which are only created when you actually need them and then can be removed immediately after. Now, it's very cool stuff, but the price of that cool stuff is added complexity along with needing to be dependent on another service. There is a higher amount of setup and maintenance than there is with other solutions. Additionally, there is Citadel, which is a project from Chef community member Noah Kantrowitz. So rather than using encryption keys to control access to secrets, it uses the AWS IAM roles feature. Now, this is very useful, and Hosted Chef actually uses Citadel because Hosted Chef needs to use auto-scaling groups. The major limit with this one is it only works with AWS. If you have infrastructure outside of AWS, this is probably not the best tool for you. So there are a few other tools out there, but these are the four major ones: encrypted data bags, Chef Vault, HashiCorp Vault, and Citadel that I've seen used within the Chef community. And that begs the question, which tool is best? How do you know which one to invest that time in setting up and learning? And the answer, like a lot of things in technology, is, well, it depends. It depends on your needs. It depends on your organization's environment. It depends on the complexity that you're willing to live with or need to live with based on your environment. But there are a few common questions, no matter what your organization, no matter what your environment, that can help you choose the best tool for you. And the first is, where is your infrastructure? Citadel only works in AWS. If you have infrastructure outside of AWS, Citadel is not the tool for your needs. Next question is, do you need auto-scaling groups or some other sort of self-healing mechanism? If you do, as I mentioned before, Chef Vault is not the right tool for you. And finally, do you have the kind of environment that needs those dynamic secrets? Secrets that only exist when you need them and when you are using them. If you are willing and able to take on the complexity associated with that, HashiCorp Vault is by far your best bet. So as we wrap up, I want to repeat this. Yes, key rotation is hard. Managing access to data, making sure the correct people and nodes can access it and the incorrect ones cannot access it is very hard, but it's not impossible. There is help out there. There are tools that can help you solve this problem. And again, I'm not going to stand up here and tell you they make it easy. They do make it easier. Remember, whichever tool you use, it is crucial to find that balance between security and usability, both to keep your information safe and to allow the people in your organization to fulfill their mission. And with that, that's who I am again. That's my contact info. And are there any questions?
Yes, I was actually just curious. Using Test Kitchen and accessing a vault was a little difficult for me. I was curious if you have a suggestion on a better way to do that.
I have not accessed a vault with Test Kitchen before, actually, so I'm uncertain of it. But if you figure out a good way to do it, make a blog post or do a talk on it next year. But I will look into it, and if I find a better way, I'll tweet it out or I'll put it on the Chef blog.
All right, thank you.
You're welcome.
Oh, just pass it back.
Got another hand up there, then we'll go over to the other side.
Hi. I think you've got some blog posts that have a lot of this information, and I've read through those and found them to be very useful. So I've kind of implemented some of this already. But there was the thing that you had in there about the setting the compile time thing with the Ruby gems. Is that a newer development? Because I don't remember that being something that I had to do.
It was not required at the time of my blog post last year.
Okay.
It is required now due to some changes in Chef itself and due to some changes in the Vault.
Okay.
Yes.
Do you know at what point that became a necessity? Because I don't think I'm doing that, and I'm not sure now if I need to be.
I don't know offhand. If it's working for you, you probably don't need to do it. If it's not, though, I would look into that. But that is a somewhat recent development.
Okay, cool. Thank you.
You're very welcome. And we had a hand up over here on this side.
Where we headed?
I would say bearded guy, but that doesn't narrow it down that much.
Narrows it down
Yeah.
a little bit. Where are we going? Oh, here?
A gentleman who's standing. Yep.
Bearded guy.
Yeah, so great talk.
Thank you.
So the auto-scaling issue is a big deal for us.
It is.
We manage thousands of bare metal nodes, and I'm constantly adding new nodes into my environments. Have you seen any intuitive solutions that are trying to tackle that problem, or does Chef have anything on the horizon that's going to make Chef Vault work a little bit better for that? I was thinking recipes. Is there something I could write that would maybe work
Right.
around that? So just curious on your thoughts on how is that problem going to be solved?
Sure. With Chef Vault, there's not anything currently on the horizon. That doesn't mean there won't be. Right now, Chef Vault is undergoing a major rewrite. In fact, I think it was just released, as Tom mentioned, to make it usable with AWS key pairs and some other things. We do realize that is a big pain point, and it is something we're going to be considering, but I don't have a good answer when that will be at this time. If you're in AWS, I would say look at Citadel.
We're bare metal, so yeah, that's not going to work for us.
Well, yeah, that's not going to work.
Yep.
So unfortunately, I don't have a good answer for that at this time, but we do know it's a pain point, and we do know it needs to be solved.
Thanks.
You're welcome.
Oh, actually, do you mind?
Yes, absolutely.
Passing it down?
Take the mic down, pass it around.
Hey, Nell.
Hey,
So one question I had is there a way to move around or back up vaults in their latent encrypted state either between servers or organizations?
right. In Supermarket, I'm not sure if it's up to date at this point. We do store the encrypted data in a private GitHub repo.
Okay.
So we do back it up that way. You could also back it up to an S3 environment. I think actually, well, again, if you're in AWS,
We
because
are.
the whole world is not on AWS, but you can back it up in some sort of static store in its encrypted state. Yes.
Excellent. Okay. Thanks.
Yep. Any other questions? There's another gentleman over there.
All right.
Thank you. Hi, thanks. So no logging for Chef Vault.
That is correct.
Is that going to change in the future, or is that set for permanently?
I wouldn't say it's set for permanent, like anything in open source. There are no plans to change that at this time.
All right, thank you.
You're welcome. All right, we got him and then him. People are conveniently clustering their hand raising. It's nice.
So this isn't a question, this is more just a comment for the bearded gentleman in the back. Nordstrom has Chef Vault Try Notify. It's a recipe. We learned a little bit about that on Monday. You might want to look into that. It, from what I understand, basically tries to retry if the Chef Vault's not available. So to paraphrase, basically Chef Vault Try Notify is a recipe that can work around it, but it has some security concerns, and there's some gotchas around it. Chef Vault Try Notify on the Nordstrom GitHub.
Cool, thank you.
Is there another one over here?
There was that guy right here, and then there's someone in the back. Let's do the guy in the front first, yeah.
Does the HashiCorp solution do audit logs?
I believe so, yes.
And I'm assuming they don't have the solution for the static secret for auto-scaling.
I believe they
they-
do, but I'm not certain on that. I'd have to verify that.
Okay.
Yeah, I have not heard of that as a limitation with them, with auto-scaling groups.
Thanks. So hopefully I could phrase this properly.
Okay.
So the vault itself was secured by who can access it from a client perspective, right? So if the Chef client is running, the vault can say that host can access this vault item.
Correct.
Okay. And then from a user perspective, the user's desktop can access the vault because of that relationship as well, right?
Because they have the key pair
Yep.
associated with their account on the Chef server, and that particular account name has been authorized to access it, yes.
So we have a use case where we're trying to run the Chef client on a particular host, and we'd like to be able to, in the recipe, specify the user that's going to access the data bag as well. Is that possible?
I don't know, actually. I think it's a very interesting use case. I could see that being possible, yes.
Okay. Because we haven't found out how to do that yet, so.
All right. I'll take a look at it, but yeah, if you do, do a blog post or do a talk next year. Any other questions? Oh, yep. Then we'll come to you.
Can you add nodes to a vault via a chef search based off a run list or name or tag?
You can. I don't recommend people do that, though, on a personal level, because if a node is compromised, the name of that node can be changed. And if it does a search across all of them, it could potentially pick up a node that it's not supposed to. So yes, you can do that right now. I just don't recommend it as an approach at this time. And there's that gentleman here.
Yeah, I guess mine was kind of similar. I was wondering if it takes like wildcards and stuff for adding like hundreds of nodes at a time to a vault.
You can use it with wildcards, yes, but just be cautious on the node
Yeah.
names.
All right, thanks.
Sure. Any other questions? All right, well, it's about 8 minutes, I don't know what early is, but early. So I think there's snacks, enjoy them, and I'll be hanging out here if you have any more questions or want to come up and talk. Thank you. Oh, you're very sweet. Yeah.